This is 2008 question 1b. Two particles P and Q, each having constant acceleration, are moving in the same direction along parallel lines. Let's attempt to draw some parallel lines. When P passes Q, let's say it's here, P passes Q, and it's now ahead of Q. Their speeds are 23 and 5.5. 23 and 5.5. Two minutes later, so it's 120 seconds, Q passes P, and Q is then moving at 65.5. So we have more information about Q than P. 65.5 is after 120 seconds. So we want the acceleration of P and of Q. Okay, let's see what's happening with Q. We seem to have more information on him. We have U is 5.5, and then at another point its speed is 65.5, and in this time period of 120 seconds it has obviously had some acceleration. So now we can work out the acceleration. V is equal to U plus AT. 65.5 is equal to 5.5 plus 120A. So 65, so that's 60 over 120. Works out nice and tidy, equals A. A is equal to 0.5. MS to the minus 2. So now that'll help me get P. So if I look at what I have for P, I have its initial velocity of 23. I have this time period that we're kind of dealing with here, which is 120, so I'm missing something. So what else can I get down here? I can get S, that P has traveled, and they meet again. So S is equal to U 5.5 by 120 plus a half AT squared, so plus 4.9 by 120 squared. And this works out to be 4260 meters. So now we know that P has traveled 4260 in this time period, and we are looking for A, the acceleration of P. So S is equal to UT, so 4260 is equal to U 23 by 120 plus a half AT squared plus plus a half A 4.9, not 4.9, plus a half A by T squared, which is 120 squared. So what do these work out to be? 4260 is going to be equal to 23 120s is 2,460, 2760, and 120 squared is 144 with two zeros, and divide that by 2. I'm going to get 72 with two zeros times A. So we're going to get 4260 minus 2760, which is 2500, divided by 7200 is equal to A, and this is for P, so that's 25 over 72. Divide it into both of them. No. See here, it's 150, 4260, take away 2760 is 1500. So 15 over 72. 3 divides into both of them, 72, not 70, which will be 5 over 24 meters per second squared, or ms to the minus 2. And that is the acceleration of P. Now we're looking for the speed of P when it overtakes Q. The speed of P when it overtakes Q. So V for P, so P again, looking for the speed. V is equal to U plus AT. V is equal to 23 plus 5 over 24 by 120. We have all the variables, and 24 goes into 125 times, so 23 plus 25 which is 48 meters per second for the speed of p when it overtakes q. And then the distance p is ahead of q when they are moving with equal speeds. Well, we can need to know the time, so they're moving with equal speeds. So let's get the speed of both. Just get the variables here. Speed of both at any time. So the distance p is ahead and they're moving with equal speeds. Okay, well, let's get their speeds. For p, we have 23 plus 5 over 24 times t. That's the speed at any time. That would have to be equal to u plus at on the other one. So 5.5 plus a, which we got to be a half, 1 over 2t. So you can solve this down. If I multiply by 2, what do I do here? Let me just do it on a calculator. I'll bring the 5.5 across. So I get 17.5 is equal to a half t plus 5 over 24t. So that's 12 over 24, 17t over 24. So if I put my 24 here, it's 12 over 24 minus 5. 12 minus 5 is 7. It will be 7t over 24. So I'll put my 7 here. And I get t. Does this work out evenly? It works out to be 60 seconds. And we're looking for the distance p is ahead of q. So we need to get both our distances now to find out how far one is ahead of the other. So my distance for p, ut, 23 by 60 plus a half times a, which was the 5 over 24, times 24 by 60 squared. And the distance for q is going to be the 5.5 by 60 plus a half a, which is also a half by t squared. And these give answers of 1755, 1230, and the difference between these is 525 meters.